All right, today what we're going to talk about are simplify, rationalize radicals, and we're going to review the Pythagorean theorem. So let's get started with simplifying radicals. So when you have to simplify radicals, what's important here is you're looking for perfect square factors. So whenever you have those perfect square factors, that's what you're going to use to help you simplify. So let's go ahead and let's get started with this first example. For the first example, we have 72 under the radical. So what we're going to do is we're going to factor 72 into 9 and 8. And we're going to factor all the way down to primes. 9 can factor into 3 and 3. And those are primes, so you're going to stop there. Then we're going to factor 8 goes into 2, which is prime, so we're going to stop there, and 4. 4 can be factored down into 2 times 2, and those are both primes also. So now what we're going to do is we're going to look for perfect square factors, or we're going to look for pairs of factors. So let's look here. I have 3, 3, 2, 2, and 2. So those are our factors. And I'm going to write it out here just so you guys can see. I'm going to list it off to the side. So it's 3 times 3 times 2 times 2 times 2. You don't have to write it out like this all the time, but I'm just doing this to show you. All right, so let's look at what we've got here. So far, I've got one pair here. And then I've got another pair here. So let's go ahead. So if you were to think of this, you're technically taking the square root of all this. So when you do that, if you were to take the square root of 3 squared, that just equals 3. So we're basically doing the same thing. We're going to find a pair. And our pair is right here. And we're going to take that outside the radical. So when we take it outside the radical, you've just got 3, but you're only writing 1 3. And then now we've got another pair with 2 times 2. And we're going to go 3 times 2. And we have this one left over. Since that's left over, that's staying inside the radical. Here, okay? And then here is your factored here, and that's here. Now we're not done yet. Now, since we have 2 numbers outside, you need to multiply those. 3 times 2 is 6, and then bring down your radical. And then that is how you simplify it. And so it's just showing you the work from there. So just make sure when you're looking for these, you're looking for perfect squares, factors, or pairs of perfect squares. And that's all we're doing here. So let's go down here and let's try these. So for 18, I'm going to do a tree. So for 18, we can factor into 9 and 2. Well, truthfully, I already know what 9 is, but we're going to keep going because I know that 2 is prime. I'm going to circle that, and I'm going to factor this into 3 times 3. 3 is prime circle, 3 is prime circle. So now let's start to find our pairs. I've got a pair here. And so I'm going to write that as 3. And then I have a leftover here. And that's going to go inside the radical since it's leftover. All right, that's it. So 3 radical 2 or 3 root 2, you'll hear both ways said. All right, now another way to factor is if you're really good with your multiplication facts and you start to notice, you can factor it to perfect squares. So if I were to factor this, I've got 4 and 6. Well, I already know 4 is already a perfect square. So I don't have to factor that anymore. So now I can just take the square root of 4 and the square root of 6, and then I'll write 2 up front. So the square root of 4 is 2, And then 6, we don't have any other perfect squares in there, so it's 6. So now 2 times 2 is 4. 4 root 6 is your answer. All right, and then here for 108, like I said, you can start looking for perfect square pairs. And for 108, I know I could do a bunch of different ways. I could do 9, if you know what that is, or I could do 4, and I could do 27. Now 4, I could keep it as 4, and then, or I could factor it all the way down. And then go through, circle all your all your primes. All right, so now let's start to find our pairs. I've got a pair here, so I'm going to go 2. And then I've got a pair here, times 3. Well, I have one guy that's left over. This guy is left over, so that's going inside your radical. And then now, simplify what's outside by multiplying 6 root 3, or 6 times the square root of 3. And that's your answer there. Now for this guy, for 512, again, you can start to think of your perfect squares. And if you know your perfect squares, an example would be 256 times 2. Well, I know that this is a perfect square, so I can just go ahead and do root 256, which is 16. So that's another way. If you know your perfect squares, you can factor out perfect squares. If not, just go ahead and factor all the way down. Whatever is left over goes inside the radical. All right, another we're going to learn about is rationalizing radicals. So you cannot have radicals in the denominator. So you need to change the fraction without changing its value. So you're basically multiplying by 1. And then how you multiply by 1 is you have your numerator and denominator the same, and that's called rationalizing it. So here's an example. So we have 5 over 10. We can't do this. So they're showing you, here's your 1. This is your value of 1. And then what you do, these two are going to cancel out to give you 10, and then simplify your fraction here, which is what they just did there. And then go ahead and square root of 10 over 2 is simplified. So we'll go ahead, we'll use that, and then we're going to come down here and we're going to do these. So now, again, we cannot have a radical, so we're going to make it an equivalent fraction by multiplying top and bottom by root 2. So once you do that, you get 3 root 2. And then these two actually make the square root of 4, which equals 2. So that's why your denominator is 2. Okay? And then now, can you simplify any more? Nope, we can't simplify any more. So that's your answer. So no more denominator, radical in the denominator, so you're good. So let's go ahead, let's rationalize this one. So you have square root of 3. So what you do to the denominator, you do to the numerator. You're multiplying by a 1. And then now, 4 root 3 over, and remember, this would be 3 squared, which equals 3, or you can think of it as 9 square root of 9, which equals 3. Either of those, but your denominator is going to be 3. And you can't simplify that anymore, so boom, there's your answer. All right, I want you to try this one, and I want you to try 8. So go ahead, try this, and I'll give you a hint on number 8. You can simplify the numbers that are outside the radical, and we'll check those. All right, good old Pythagorean theorem. A squared plus b squared equals c squared. Remember, your legs make the right angle, and your hypotenuse is opposite the right angle. So I'm only going to do a couple here because this should be a review, but just remember when you're doing this, you're going to go 8 squared plus y squared equals 12 squared, and then go ahead, simplify. Subtract 64, and then you're going to get y squared equals 80. Now, take the square root of both sides, so you get y equals root 80. Now, this would be one answer, but it's not simplified. So now we have to simplify the radical. So to simplify, you're going to take root 80, and you can factor it out. I know that this is 4 times 20. And this one I could take square root of 4, that's 2. And then 20 I know is 4 times 5. And then this I know is 2. And then I have a leftover of 5. So now your final answer should be 4 root 5. So this is your final answer. So remember, this is not simplified. You have to simplify. All right, so go ahead, simplify. All right, so same thing here. If you were to do this and go ahead, set it up. Sometimes not all of them can be simplified, and that's okay. So remember, 3 and 10 are your legs. C is the hypotenuse. All right, solve for C, take the square root of both sides. Now C is going to equal 109, root 9, 109. And the reason being, we can't simplify anymore. So this is as simplified as you get. All right, I want you to try this. Here's your hint, draw a triangle. All right, so that's your hint. And then you're going to go ahead and you're going to finish this problem and simplify the radical. All right, and then that is how we do simplifying radicals. Remember, you need a pair of factors or a pair of perfect squares. And then to rationalize, you're multiplying by 1. So what you do to the numerator and denominator, do the same thing, and then go ahead and do that. And with Pythagorean theorem, all you got to do is do a squared plus b squared equals c squared. And then remember, if it's not simplified, you have to simplify your radicals at the end.